All right, let's explore the invisible force that powers our entire world, current electricity. From a lightning bolt to the light bulb in your room, it all comes down to one simple thing. Here's what we're going to cover. We'll look at what electric current actually is and even how to solve any circuit. So, what exactly is electric current? It's really just the rate of flow of electric charge over time. It helps to think of it like water in a pipe. The more water that flows per second, the stronger the current. All right, let's get to the master rule of all circuits, Ohm's law. It connects voltage, current, and resistance. And what it means is pretty simple. More voltage gives you more current, but more resistance means less current. So that begs the question, what actually gives a material its resistance in the first place? Well, a couple of big factors are the wire's length and thickness. A longer wire has more resistance. And that's all captured in this formula. That little rho symbol stands for resistivity, a property of the material itself. But what's really going on with the electrons inside that wire? Let's zoom way, way in. If there's no electric field, electrons just move around randomly and collide. There's no current because they go nowhere. But when you add an electric field, they get accelerated. The collisions create a slow, steady drift in one direction. See that dotted line? That shows the slight drift of the electron's path when you apply that electric field. That slow average velocity is what we call drift velocity. It's what creates the steady current we use. Okay, we've got simple circuits down, but what happens when things get a lot more complex? Well, luckily, we have Kirchhoff's rules, two simple guidelines that let you solve pretty much any circuit. The first one is the junction rule. It just means the total current going into a point has to equal the total leaving. The second one is the loop rule. It says the sum of all voltage changes in any closed loop has to be zero. Using just those two rules, you can analyze even the most complex electrical networks out there. They're super powerful. So let's quickly recap. Current is the flow of charge, and Ohm's law is fundamental. Resistance and electron drift are key concepts. Understanding this flow is understanding the backbone of modern life. It really makes you wonder, what will we power next?